So you can start.
Thank you, Liza.
Oh, and just one thing more, I would like to say that Professor Marcelo here is not today because he had a personal matter, so he could not attend. But
Okay.
I'm advisor, co-advisor of Geovane, so yeah, taking care of the defense.
Okay. Thank you very much, Liza. Thank you, everyone who is here. Good morning and good afternoon for those in a different time, global time. And well, I would like then to begin with my PhD defense. Just to make sure you can see my, those who are remote, you can see my pointer.
Yes. Small, but yeah.
Oh yeah, really small.
Okay, all right. Okay, so this is the presentation of my PhD research. It's entitled Protecting Interactions in IoT Swarm, a self-sovereign and attribute-based approach. My advisor is Professor Marcelo, and my co-advisor is Liza Costa de Biasi. So here is a brief outline of my presentation. I'll begin with the introduction and presenting the problem. Around a decade ago, Professor Jan Rabai proposed the concept of IoT swarms, where the concept of mobile computing was getting expanded and also aligned with the concept of the Internet of Things, where the idea is to enable creations of sensory swarms, which are very tiny and small devices that are able to sense and interact in the real world. This idea was later captured by Costa, which in 2015 proposed the definition that swarm is a heterogeneous distributed collection of heterogeneous things. So it's very much inspired in nature, and the idea is to enable devices to cooperate and communicate. For example, here we have a home use case where several devices are in a home use case with several owners and even outside entities forming not only a home use case but also a smart city. You can think of this, for example, in very dynamic scenarios where, for example, a camera installed on public spaces can be shared, for example, to help the police solve a crime. And this is a cooperation in the swarm. But how to do that? Well, Costa proposed the control plane for creating swarms, which is the swarm broker. It provides several services, including, for example, registry. So when registry, contracting, and so on, the idea is that, the idea is that the control plane, also called the broker, can be embedded in each IoT device. So in each device, a broker is installed, and the broker provides services to application agents. Another way we can think of the swarm is as the paradigm where it enables...
Sorry, I would like to ask to turn off the mic, please, for that. Yeah.
Thanks. So with the idea is to allow the emergence of a collective intelligence out of trillions of devices. This requires several principles to be implemented, and one of the most important ones is security, defined as a condition that results from the implementations of measures to protect the system. So how can we protect swarm systems? This is the problem that I am tackling in this dissertation. How to enable secure interactions in IoT swarms. In this context, there are several requirements that need to be addressed for this, for implementing swarm security. It needs to be flexible because of the cooperation. So it's not possible, for example, to create identity-based rules between access between very specific devices. It needs to be decentralized because swarms are inherently decentralized, which means that devices must be autonomous, and therefore it's required to have embedded execution. There are several solutions already existing in the internet and the Internet of Things for doing so. One of the most common ones is using accounts and passwords, which is not scalable for IoT devices. Transport layer security and datagram transport layer security is very mature and very well tested already. However, it can only be used in IP-based networks. If you use a proxy, you break end-to-end security, and it depends on centralized public key infrastructures. It's also very common to have cloud-based IoT management systems which manage identities and access control. However, they are also centralized. A very common approach for decentralization is token-based authorization. However, how to generate this token is commonly also centralized. So we can also consider that the current zeitgeist of kind of a re-decentralization of the web, and we also can look at this way to the IoT, where we have blockchain, Web3 emerging, self-sovereign identity, and IoT swarms are also part of this trend from going from the cloud to the edge. So to achieve a secure swarm, we take the approach of using self-sovereign identity and attribute-based access control. I'll give a brief example of what this means. So in self-sovereign identity, the idea is to use each entity, each and every person, device, or thing has its own identification. This identification is self-generated, self-controlled forever. No one can cancel your identity. So that's the main idea. It's an evolution paradigm. It's being standardized by both the W3C and the Decentralized Identity Foundation. However, it's being created these standards are created for the web, not IoT. So sometimes they are not compatible with the requirements, especially on constrained devices and networks. Also, briefly about attribute-based access control, the idea is to have each agent with a few attributes, and then you can create policies based on these attributes. For example, here, friends can update a lamp. So these policies are based on attributes. They're not, I don't know who is the friend. I don't know if it's Bod or Alice, whatever. The policy is more simple and more scalable. However, some challenges here is that these approaches tend to require authorization servers, and there is no standardized policy format, different from self-sovereign identity, for example. Okay, and now we are going to start into the literature review to see some related works. Starting with digital identity. So the most, one of the newest approaches in this area is self-sovereign identity, as I just said. In previous analysis, we concluded that it improves ownership, privacy, and fosters decentralization. In self-sovereign identity, the technological approach uses decentralized identifiers and verifiable credentials. Those are two separated layers. One of them is focused on identification, and the other one is focused on more user-level attributes. How can you trust in user-level attributes? DIDs use a meta specification, which means that you need to create concrete proposals, which are called DID methods. This is important because I will show later in the framework that we proposed a new DID method. And in self-sovereign identity, it's common, but it's not necessary to use blockchains. It may be helpful in some cases to make the system more flexible. Here's an example of a decentralized identifier, here in red, DID example, and then a randomly generated string. The DIDs usually are also part of a DID document. They can be shared independently, but they are usually connected to a DID document. The idea is to have a machine-readable set of metadata to enable sharing public keys and service endpoints. Why this is helpful? Because let's suppose how we use, create, or use a did. So here in step 1, let's say Alice creates her own did. Remember, it's self-sovereign. She generates its own did and did document. Then Alice registers the did document on a public ledger. After that, if Bob has Alice's did, Bob can resolve Alice's did document with her public key and service. Why this is useful? Well, because then Bob knows the endpoint to connect and the public key to establish a secure channel. And this is usually done using the DIDCOM protocol. It stands for DID communication. It's a protocol for secure channels between DID holders. It's transport agnostic, can work across proxy, and provides async communication, kind of like email. However, it uses JSON and was not designed for IoT device, so it may be a little too heavy for constrained networks. Then I said self-sovereign identity has two main technologies. We talked about DIDs and now verifiable credentials, which are a list of claims to enable trust in certain attributes. So here we have an example of a credential with a name, a birth year, and a proof. And here a more detailed example where the credential subject is identified by a DID, and it has a few attributes. Here is a cryptographic proof in the bottom. And here in the top is the issuer, is someone who signed this attribute. Okay, another example of how to create, let's suppose University of São Paulo creates a faculty credential, then this credential is sent to Alice because it says that Alice has the role faculty. And here is the signature by USP. Then if Alice presents this credential to Bob, Bob is able to resolve his the university's DID document and check if the signature from the issuer matches the credential. So how can we adapt this to Internet of Things, this approach? So basically, we can have devices generating their own DIDs and DID documents. Optionally, they may anchor them on a public ledger and communicate using DIDCOM. So we have an example here where a user or owner generates their own DIDs and then handles a credential to a device. Let's say during the provisional step, the credential says that the owner of the device is ABC123, which is the DID of the owner. So with this scheme, it's possible to establish ownership of IoT devices. And here is just to emphasize that agents can also communicate using the documents, resolving them from a ledger, and then using DIDCOM to communicate. But is this enough to have it work? Well, actually, since these models were made for the web, they're using too much bandwidth and maybe too heavy for some IoT networks. For example, in LoRa 1, we only support 240 bytes. Okay, and we may be wondering now, well, self-sovereign identity, okay, it's here, but there are already other solutions that exist, such as certificates and pretty good privacy, which are two very common uses for identification. Here we have a brief comparison where we compare initially the use of identifiers for pretty good privacy, certificates, and self-sovereign identity. So for example, PGP uses name and email for identifiers. These identifiers are inherently centralized. You depend on a DNS server or an email provider, so it's not scalable for IoT. Certificates use qualified names that also require some level of centralization because there are namespaces. Then usually on DIDs, then the number are randomly generated locally, and then only after locally generated, they are stored on a blockchain. So it reverses the process and is decentralized. We can also look at, for example, how only the new standard supports semantic schemas to enable advanced matching, and also the use of service endpoints, which was only introduced in self-sovereign identity. It enables when two devices find these documents, it's automatically the machine can parse and directly connect to establish a secure channel. Okay, next we turn to access control. So the idea of access control is the problem of determining which subjects can perform which operations on which objects and under certain contexts. For example, let's say we have that researchers can open entrance gate from 6 a.m. to 6 p.m. So subject, operation, object, and context. How can we organize this using already existing access control methods? So we have a few models that are more common. Access control lists, they're identity-based, and they depend. You need to name each of the entities in this list. This list can grow very large. Capability-based access control inverts this logic because the capability, it's like the ACL is spread among all the devices, but then you have to configure each device with each of the rules. Role-based access control is better because you abstract the part of the subject. Because you can say a specific role, but then you still need to name each of the identities on the other side. And then attribute-based access control is the most flexible solution, where you can just use attributes to several attributes of all the types to configure this access rule. And there are still a lot of research on attribute-based access control to try to decide, okay, since it's so flexible, it's like you can do everything, but then it's complicated. It's not possible to just say you can just use everything. You need to define a model or kind of a formal way or how these policies will work. So there are two main ways of defining ABAC models. One of them is enumerated access policies. The other is logic access policies. Logic-based use like logical formulas where you can use a, and, or statements to create complicated rules. And enumerated, you just enumerate all the possibilities. And in BISWAS 2017 compared these two approaches. And for example, although logic-based LAP allows rich policy language, it can be difficult to automatically update it, for example, in an algorithmic way. And it's also more complicated to process because it's more, you have to parse all the logic. And then for enumerated policies, you create very small policies, and however, it supports limited operations. It's kind of more simple and then more limited. But since EAP creates micropolicies, maybe it's a good idea to put them on IoT devices because they will be fast to execute. So maybe we can improve EAP to make it more expressive while keeping it lightweight. This is one idea that I will explore later. Also, when looking at related works in ABAC, in Internet of Things, we have that most existing works depend on servers to evaluate complex policies. And in our proposal, we will show an approach that works only with IoT devices directly. Okay. Then finally, about IoT security, let's just look at here. The first rows, we have IoT standards, and see that they mostly use TLS or DTLS, which depend on public key infrastructure and are centralized. Other approaches use DIDs and VCs, but they do not cover all of the, for example, they do not cover necessarily a flexible authorization model. We only see identity-based or CAPBAC. And finally, other approaches for IoT in general, there is not yet a full approach proposing a full integration of self-sovereign identity and attribute-based access control on embedded devices. Okay, with this, we go now to the framework implementation that we are going to propose. Just one moment. So the framework we propose is layered. We have 4 layers: authorization, authentication, confidentiality, and identification. This framework is embedded in IoT devices. So the idea is that the whole framework can be embedded into the devices, providing the whole stack of security. So let's begin exploring the authorization layer. Suppose we have a user trying to access an IoT device. How can we authorize and decide if this user can access? Well, NIST defined a reference architecture for ABAC, where you have the one who is trying to access is the subject, and the receiving one is the object. And the idea is to use a server here to do an enforcement and intercept the request, send it to a decision point, and then this decision point will load access policies and will load attributes from repositories and compute a decision. So how can we adapt this architecture to work in the context of embedded IoT? Well, we adapted it to work with the Swarm broker that I explained in the beginning. So we added an access control module to the Swarm broker. In this module, we have the decision point, the policies, and the attributes of the object, which is this one here, the responder. And when the initiator or subject wants to send a message, he has to send his attributes, because to send his attributes, then the attributes will be sent to the PDP, the decision point. It will evaluate the policies and send back an access decision. And this framework was designed to be fully embedded into IoT devices. Okay, and then after the architecture, we need to define the model which specifies exactly the format of these access control policies. We took the enumerated policies approach and making it more expressive. Basically, what we did, we added data types, the attributes, and this enables specifying if an attribute is of string or maybe a range and so on. And this does have a very limited impact on processing time. It also supports hierarchies, so you can even expand it with semantic schemas to create hierarchies that can be used to match more general attributes. And the framework is able to run on highly constrained devices. So here we proposed a logical definition here. I will just focus on the important things where we have attributes with data types, string, number, ranges, or maps or associative arrays. And then we define also the policies, which comprises operations, subjects, objects, and context attributes. And then these policies will be used to match here in the bottom with the definition of a specific request. So I will show an example of policies based on this model in a moment. Let's look into a use case where we start the evaluation of the authorization layer. So we have here a smart house where we have 2 rooms, the parents' room, the child room, and the entrance. In the parent room, we modeled Alice as a persona, which is a Swarm agent that represents a person. And she has a few attributes: type user, last name, age, and also the household. Note the household is a nested attribute. Nested attribute means that there are more attributes inside the household attribute. Then we modeled Bob in a similar way, and they also have a lamp. It's of type light bulb, has a specific manufacturer, and so on. And the owner of this lamp is Alice. So Alice owns the house and all of the devices, except the persona ones. We have car, the child, age 10, role child. We have another lamp, And finally, we have a camera which is located outdoors in the entrance. So we can use these attributes to create access policies based on smart ABAC, which is our proposal. So here on the top, on this table we have access policies that we created trying to exercise the framework. So how can we create several different access policies considering real IoT use cases? In the first one, we have the policy which says Alice can do anything with her own devices. We can model that using the attributes we just saw. ID Alice can do several operations where the object has the attribute owner Alice. Similarly, we can model policies for attributes using security appliances and several other kinds of policies. We evaluated the smart ABAC against existing literature on several aspects. So here are several works, and then here on the lines we have the aspects we compare. So if we look at the features, we see that smart ABAC is the only model, the only enumerated model that uses data type, and all of the models but the policy machine support multi-attributes. We then compare the expressiveness of these models, considering the expressiveness here was thought of, okay, what we need to make, considering IoT networks, considering verifiable credentials, how to make the whole thing work together. So we need to be context aware, and so on and so forth. We need to support several protocols, for example. Next, we try to model the proposed policies using existing literature, so we can see that only smart ABAC can model all of these policies. We also checked if these implementations, the other models have implementations, if we can compare with them. So we'll present a comparison with the ones that have open source solutions. And we also see that smart ABAC was the first one designed to work inside very constrained devices, such as microcontrollers and so on. So this test was executed on a laptop because some implementations used high-level languages. So for example, XACML is a very known in the industry. It uses Java. And then we can see that smart ABAC, when implemented in C, it's very fast, and it's up to 55 times faster than the other one, the second best one, which is XACML. Interesting to note that the size of the code base is very small compared with XACML. This is important because IoT devices have small memories, so there's not much of penalty here. It's just the way the model is organized. We evaluated also the model in constrained devices. So here we have the Puga, for example, which is the most constrained one, single core 32 megahertz. And to evaluate one request against 3,000 policies, it took less than 5 milliseconds. The policies were 5 milliseconds. Yes. Yeah. Mm-hmm. So yeah, it's a negligible execution time, even if you have a complex network with many and many access policies. Okay, so this was the authorization layer, and next we go to authentication and confidentiality. For authentication, we use verifiable credentials, which, as I said, enable trust in user-level attributes or device-level attributes, let's say. So these are application specifics. And the verifiable credentials are based on the W3C specification, but we adapted them to more, mainly to use binary serializations based on CBOR, and then COSE, which is a specification for creating signed blobs of data. These specifications are commonly used in IoT scenarios. And it works where all entities are identified by deeds, then an issuer signs the attributes, and a verifier can then test the issuer digital signature. So here's an example. So everyone identified by deeds, and here are the example attributes. Then for confidentiality, we propose a linear DIDCOM alternative. Remember, DIDCOM was the protocol to enable secure communication between self-sovereign entities. So we proposed a binary header for DIDCOM and also reduced the header. So we call it decentralized IoT communication, or DIoT-COM. It works basically using the binary envelope, using a minimal header, and the sender encrypts message by using their own private keys and the receiver's public keys, which were obtained by the DID document resolved from blockchain, or maybe even could be initially hard-coded on the device. It's also possible. We compared the proposed framework considering the STRIDE threat model, which stands for spoofing, tampering, repudiation, information disclosure, denial of service, and elevation of privilege. We look at spoofing of identity. This means that someone could fake the identity of a device. So the point of view of the communication protocol, the way to mitigate it using authenticated encryption or digital signature. We use here AES, or elliptic curve digital signature, or more specifically using the Edwards curves. So that's why it's ED here. Then we mitigate tampering of data in message, also data in transit, with AES. We mitigate repudiation of messages using digital signatures, and information disclosure is protected by the use of AES after doing a key derivation. Finally, the denial of service and elevation of privilege is considered out of scope for this specific layer of the framework. When comparing DIoT-COM to DID-COM, which was the original one for self-sovereign identity, we see that DIoT-COM messages can be up to 5 times smaller than originally, and it's able to fit in a LoRa packet size, which is only 240 bytes. So it enables us to use in such constrained networks. We also analyzed if there was a performance penalty, and we could see that it does not, because it uses similar algorithms. It's only serialization that is different. Finally, the most foundational layer is the identification layer, where, if you recall, the DID specification proposes, it's actually a meta specification. So I propose here one of the concrete implementations for DIDs. We call it the swarm DID method, where we define what is the prefix to be used on the DIDs. The DIDs, we define it to be very small, only 16 bytes. We have also small public keys using Edwards curves, which enables only 32 bytes for each public key. And we define that it's mandatory to have a service endpoints, because in the original DID specification, it's not mandatory. So some DID methods already existing do not provide endpoints. So here is an example in the left of a JSON serialized, but we also proposed an alternative, which we call CBOR, DID documents for IoT, CBOR DI, where if we serialize it in binary using CBOR, we can greatly reduce up to 4 times the size of the original DID document. This enables it to send through LoRaWAN, or even 802.15.4 and Zigbee, for example. So here, just to visualize where the contribution stands, where if an agent needs to resolve a DID document from the blockchain, it has a greatly reduced overhead. We compared it with existing DID methods. We can see that the DID is smaller, but also the DID document is almost roughly 4 times smaller than others. We compared the serialization time, if it has a difference, and it's actually a little bit faster because it has less data to process. And okay, that was the identification. And now we look into the integrated framework. So the architecture we adapted from NIST. The model, we proposed Smart ABAC. For authentication, we use verifiable credentials. confidentiality is proposed by the IoT Com, and we achieve identification using the swarm did method. Well, let's look into how this fits together now. So, recalling that the goal of the framework is to be fully embedded into IoT devices. Now, to implement the framework, the first thing to integrate it is to define a data model that is able to integrate all of these layers. So all of the devices need to have everything, all the information they need to work. So the proposed is the data model where the agent has a did, and the did is linked in a did document and also linked in verifiable credentials, VCs. And we also defined that verifiable credentials can be public or private, because in the swarm, the attributes can help in the discovery mechanisms. So sensitive attributes are kept only locally, and then public ones can be searchable and published to some kind of registry. We also have private ABAC policies because they contain sensitive information, a private key store to store in private keys, and we also need a list of trust anchors. So when someone presents a verifiable credential, how can I know if this issuer is trusted? So for now, we use a list of trust anchors. Then this whole data model, it's embedded into the IoT devices so that they can be fully self-sovereign. Then let's look into the interaction, how the interaction works. Well, it's two steps: setup and then use. In the setup, it happens once, and then per interaction. Then the idea is that the initiator will try to obtain a token, and after that, it will present and use the token. So with a few more details here, let's suppose an initiator, Bob's persona agent, wants to get a token to access the lamp. Well, it will establish a secure channel with the swarm broker, which is the responder. It will ask authorization, sending the Bob's attributes to the broker. The broker will check the credentials, which contain the attributes, and see if the credentials match the signature of the issuer. Next, on step 4, the ABAC policies, the smart ABAC policies will be evaluated to see if the attributes match the policies. And then finally, if all works, the capability token will be generated and sent back to the IoT devices. With a little bit more of detail, we have here the Bob, it has the data model here, where with the did document and the verifiable credentials. Similarly, Alice's lamp has the did document, verifiable credentials, but also the ABAC policies, where it states that friends of Alice can read or update objects owned by Alice. And then this attribute owned by Alice is here in the verifiable credential of the lamp. And here is the list of trust anchors. Oh, and by the way, here is the capability token that is generated on step 5. Notice that the ABAC policies are created in terms of attributes, so they're very generic, but then the capability token is identity-based because it's simpler to process and will need to be carried around. Then after the initiator has the token, then it can just execute and establish secure channels and send the message using the token. Then the receiver will verify the token, and it expects the token to be signed by this broker, which is on the same device. Okay, then let's look into an example of how this can work more concretely. So Bob has a did document and a few credentials, including friend of Alice. Then Bob will try to toggle a lamp, and the lamp has the policies that we just saw. We implemented and measured this in real IoT devices using SwarmOS framework. And when we evaluate, we we notice that on average, the packet sizes have 509 bytes of sizes for the setup interaction, and for the use, it's smaller, 300, a little bit more than 300 bytes. And we can also verify that there are some overhead when the bulb communicates to the lamp, but also when the lamp communicates to the chain, to the DID chain, to resolve the DID documents. Here is the request, and here is the response. But this can be cacheable, as we will see in the next slide, where we measure the time metrics for the setup phase, for example, when Bob talks to the broker. So here we have a fairly distributed amounts of time for each part of the processing. And here in the broker, if we look, for example, in the first time of the execution, we have a very long time necessary to resolve the DID, because the DID is an outside call that needs to go to the blockchain. But after that, we are able to cache the DID document, and then this time is greatly reduced to only 60 milliseconds. Then, yeah, okay. Then after this, when Bob has the token, then Bob communicates with the lamp to obtain the token. This in green here, the lamp processing, is the network time, and the rest is what Bob processes on his side. And the other side, we have the times for processing on the lamp side, which is arguably should be the most complex, because the lamp has to verify the truth of the token. And actually here in the orange one, I just realized it should say here token, verify token. It's quite fast. So we actually have a bit of overhead here of the Python implementation. It's not even, so the verification of the token is kind of fast here. By the way, this implementation was executed in a single bird computer, in an ARM computer. Okay, and then next we go to the framework implementation, where we show how we integrated. The whole framework was implemented using a set of libraries and agents that were developed or modified. So for example, the first row, in the first row, we have the Swarm broker, which encompasses all of the layers, and it was heavily modified to enable this framework to be integrated into it. I will just show the most important here. The Swarm lib, it's also a library that was heavily modified, and the four below here, they were created from scratch to enable, for example, smart ABAC processing, both in high-level and low-level languages, and processing for COSA standards, so there was not implementations for some languages that we had to implement, and so on. Next, we have an overview of the Swarm OS framework organization, where in each IoT devices, we have, as I said in the beginning, we have a Swarm broker, and then several agents. And each agent, it uses the Swarm lib to facilitate its implementation. So we have many IoT devices using this approach, and then a few blockchain nodes. The blockchain node has the DID chain, which was implemented as a mock to store the DID documents for the IoT devices. And the economy and the reputation chains that you see here were already pre-existing infrastructure of the Swarm OS that were developed by the Swarm group here in University of São Paulo. And if we look into the broker, for example, how we contributed to it, basically we added a module for authorization to evaluate policies and generate the token. And this module depended on these libraries here on the right to be implemented. We also added authentication module with credentials and a secure communication module. In the Swarm lib, we added a module for verification of capability tokens, so the agents can verify the tokens, a module for secure communications, and also a command line interface for doing the management. So, for example, here, you can just run a command line interface to create a new agent, then use the interface to issue credentials, for example, from Alice to the lamp. Then the lamp can import this credential into their local data store. And we also have commands for adding new access policies. So, for example, a policy here stating the age of a subject and household. It's just an example that we saw earlier. We also used the framework in some IoT pilots. So, for example, where we developed a small device for where the idea is to monitor the environment and identify risk situations from images. And this device, the idea is to make access from events in the public security services faster. So usually someone has to call when something happens, and then with adding intelligence to the vehicle, it can automatically notify. We are starting pilots with the police of University of São Paulo, installing this device, and we installed the security framework in this device. We configured it to be, while it's still in field tests, we do not use the blockchain, even because the police doesn't want this kind of things yet. But we use hard-coded DIDs, and with this, we also can highlight that the solution is flexible. We do not necessarily actually need the blockchain. We can use it in several configurations, and then we also did not enable discovery because we are still testing. However, we did tests in laboratory integrating fully with the Swarm OS. So looking back into this example, we modeled it, for example, in the data model where the police car has a few verifiable credentials, saying, for example, that it's a public security service. Then in the Alice's cameras, we can create the policies stating these attributes. And then, for example, the policy states that only cameras that are located outdoors will enable these kinds of access. And here I have a demonstration of a similar setup, where here in the bottom left, we have the device with the identification installed. I will run two devices. One is the actual one, and the other one will be run in my computer, which will be simulated, and it will use pre-recorded images. So let's just go faster over here. Okay, so this is the actual image. Oops, it's too fast. So here, top right, when I configure a Swarm agent of being a police car with the attributes we saw previously, then we tell it to look for frames, up to 2 frames in the Swarm. Then when you press enter, it finds 2 results via the Swarm discovery, which is part of the Swarm OS framework. Then when I tell it to execute the reading of the image, we have the 2 results. The left one is real time, getting my arm from this camera, and the right one is a pre-recorded footage from the street. It's also possible to look for specific targets. So I'm showing here a license plate to the camera. The camera will detect the license plate, and then after that, if the police car looks for license plates, it will be able to find the image. Okay. And here they are. I'm just organizing the screen, but yeah, so it was able to find the 2 license plates. One pre-recorded, the other one was from in real time. Then if we use a different different user, which is Bob, which does not have the credentials for accessing the images. It finds the two results by discovery. It's hard to see, but it shows here in the bottom. And when I try to access, it denies the interaction because of the lack of the attributes. Okay, so this was the demonstration, and now we head to the conclusions. Overall, we proposed the research of a framework to protect swarming agents, to enable confidential, authenticated, and authorized communications. And satisfying key requirements of IoT Swarm, particularly autonomy and decentralization, and also heterogeneity for constrained networks using self-sovereign identity. Specifically, we also proposed an embedded architecture and model for attribute-based access control that was smart ABAC. It was tested on highly constrained devices. We proposed a lightweighted method for self-sovereign identity in IoT and a network agnostic protocol authenticated using SSI primitives. In conclusion, we implemented and evaluated all of the proposed ideas. Smart ABAC was tested in very constrained devices. The framework as a whole was integrated with the pre-existing SwarmOS infrastructure. It was tested in embedded devices and using both laboratory and real-world tests, thus finally enable fully self-protecting swarming agents. During this work, as next steps, we plan to fully port the framework to constrained hardware, further reduce the overhead of the communication, evaluate in larger networks, and investigate flexible trust schemes, for example, by composing it with related work in swarms with reputations and economies. During this work, we published Smart ABAC specifications, an article to the IoT journal. The architecture was published to the Transactions on Consumer Electronics. We had also 2 works about self-sovereign identity published in the Global IoT Summit, and a few other works published, co-authored in the Swarm research group here in USP. I would like to thank my advisor, all of the professors that are participating here, other remote professors as well, and everyone who is here and everyone who is watching, and all of the people that have helped me with this long journey. So thank you, everybody.
Thank you very much.
Okay.
It was a really good presentation, just in time.
Yeah.
Yeah, okay, really good. So now we are starting the.
Sorry, Liza, we cannot hear you very well because you are. I think we are hearing through the other laptop, not yours.
Okay. Yes. So do you have? Okay. No. I will try again. No.
Now it's okay. Now it's okay.
Okay, so no, I was just saying thank you very much to Geovane. That was a great presentation. And now we will start with the discussion of the work. Okay. The order of the professors that I'm planning is to start with Professor Ana Rabai, then go to Professor Antonio Scarmeta, after that Professor Pedro Maló, then Professor Pedro Rossi, and finishing and closing the presentation, Professor Flávio Soares from University of São Paulo. I think around 20 minutes will be a good time, but if you feel that we need more, it's okay. And okay, so we can start, please, Professor Rabai.
Thank you.
Thank you, Geovane. You managed actually to put an enormous amount of work and condense it and compress it in a short period of time. But congratulations, you've done an amazing amount of work, and it's a really a very coherent story.
Thank you.
Now, I have a set of questions. The first one is a very simple one. I'm just thinking about a real scenario and how it would work with your scheme. Suppose I'm Alice. I go to the store, I buy a lamp, I bring it to my home. What do I need to do? What are the different steps I need to take to make your whole system kind of be operational? What do I have to enter? What's automatic? How does it play?
Okay, so what we have in mind? You bring the lamp at home, and it either has auto-generated its identity on the manufacturer, or can generate at your home. Actually, it's second better because the manufacturer doesn't even need to know the identifier. And then you can have like a provision procedure where you can like pair your device and provision. The first thing is to provision an ownership credential to the device. Then this could be an app. Oh, click here to say that you are the owner. Then you just send the credential. Other things that we have in mind. The device already comes with a pre-bundled policy. Because it's already a lamp, it can light or dark, and usually is used in certain contexts, so can be with a few access points already embedded into the lamp. The manufacturer can do that, and then you can just review. This looks fine. I will just accept. It should be shown in a since the policies are not very complicated using logical language, can be even easier for the user to understand and review the policies.
So, for example, a TV could be an entertainment device. So in your house, you have your policy that you say, okay, all my friends can use entertainment, but safety, no, just the owner of the house person.
I understand that, but the question is, how do you do that effectively? Do you have to go on a keyboard and enter some of those policies, or do this policy built in, or do you have a simple way of introducing them? Because again, you try to basically create a system that's easy to deploy. Yes. And so there's many different entities that have to be entered.
Yeah. Okay. So we have one idea for that, which was actually explored in the paper about the architecture, where you kind of do a swarm discovery. You have many devices, and then you grab all the policies of them, and you download them to your app, and then you edit the policies. And then you just click and they are spread again to the appropriate devices.
Right. Okay, I see that. So yeah, and actually some existing home devices do something very similar, where you can set up schemes and like that. So, good. Did that help? That's very helpful. So the other questions that I have is, and you basically, in order to reduce packet size, you give up on something. Right? You basically either reduce the amount of information you can have, or you serialize it. What are the penalties of that? And what are you paying for it? Like, for instance, why serialization? Or what's the disadvantage of serialization? So much smaller. Why not always do serialization? For instance?
Okay. So there are two penalties actually. What I tried to do was try not to lose the essential information that the system can work. But for example, when I reduce from a string, from human readable string to a number, then I need to have a schema on both sides to reconstruct and show for a user, for example. On the IoT I reduce it to just one parameter, which is the sender. So the original DIPCOM allows you to route through a few proxies. You can determine which proxies you can route your message. Then here I removed it to make it like you can put this information, for example, in a co-op header in the application layer protocol that goes inside the DIPCOM message.
But overall, I think there's no other disadvantage from a functionality perspective or anything.
No. Yeah.
You don't need it. Good. In terms of footprint, you basically have managed to get, so if I think about a complete system that you want, broker, discovery services, you name it, all the type of things put together, what's approximately the footprint that you need today? And is it acceptable for most of the devices you think about, like the Buddha, for instance, or are there some limitations still of what you need?
If I had 1 kilobyte packet size packets, it would be fair. Like this message usually take up to 1 kilobyte, for example. 2 or 3 or even 5 would be excellent. I would need to worry, for example. But with 1 kilobyte, it's possible to make it work, for example. Because when you send a credential, it's at least 200 bytes. So if you want to send 4 of them and then a little bit of overhead of the protocols, then you can send 4 credentials, for example. If you need more, then so this is the order of magnitude of packet size that we need.
I understand that's packet size, but in terms of code size.
Code size.
Yes.
Okay. So it's a bit hard to answer, but one interesting thing is that we are using, for example, CBOR. CBOR is a binary serialization. Then we also use COSE. COSE is built upon CBOR. So I can use the CBOR library. So this part of the program of CBOR can serialize the DID documents, but also serialize the part of needed for COSE. So I don't need to duplicate. It's not. And then COSE is used on multiple parts. It's used for DIoT, it's used for serializing the verifiable credentials, and used to serialize the token. So it's the same technology. So the same library can do many things. And it's also possible to integrate, for example, with co-op, and then it's a very low footprint. So I have a strong feeling that it's possible to put in small devices.
Good. So obviously your target is to build a system that's very robust, safe, and things like that. What would be, if there's any vulnerability to your speed? Okay. What would it be?
Interesting. Very interesting. So I think what I would do. The first thing is when the IoT device is engineering, it should have some way of updating these critical parts, or at least updating the firmware to solve the vulnerability, for example. And where it could be, for example. Well, maybe one of the questions that you asked before, where I was giving up on something. So for example, when I use DIoT, I am using static public keys. And these keys enable creating very strong security, but they do not provide the property of forward secrecy. So if in the future someone discovers your private key, which should be started in a trusted module, then in theory they could decrypt the previous message. So this would be a possible one. And we are thinking also in adjusting the IoT to support interactive key exchange. So this would solve that problem.
But suppose somebody can hack into your node. Okay. And as an example, right? Okay. Would it be possible to basically change authentication lists or anything like that at all, or is this?
So the thing to do to prevent that is to use hardware protected what we call trusted platform modules. So the private keys must be stored in those modules, and then when someone logs into the system, they cannot read it because they can only be read by silent code, for example.
Good. So kind of my very last question is about standardization. Right. It's a great scheme, wonderful, so it's also a problem. How can you make impact with it? How do you see this progressing? There's a number of standards that people are promoting out there.
Yes.
How do you think your scheme can make inroads and ultimately be adopted? what's your plan for that, or is there a plan?
Well, I have two main ideas. One of them is that smart tobacco, for example, could be evolved into an IETF request for comments, for example, for protecting locally these devices. I think specification could be written in that scheme and published for the community. And the other idea is to integrate with, there is the decentralized identity foundation, which has proposed Bitcoin, for example. So it would be an idea to try to integrate Bitcoin with this foundation and with the standard.
The IoT.
Yeah, the IoT.
And your deed, you put in the.
I have
to add it to the public ledger.
Oh, you haven't yet?
But yes, I can do that. Possible to publish.
Because that seems to be an important part, right? You did an enormous amount of work, and again, congratulations for building a complete integrated system and looking at all various aspects. It would be a shame to kind of get stuck in one local realization and not having a problem. Again, that's what I have a question. Congratulations.
Thank you.
Thank you.
Thank you very much, Professor Rabbi. Now we can proceed with Professor Antonio Scarnetta, please.
Yep. Can you hear me?
Yes.
Maybe you need to.
Just one
okay.
Moment. Sorry.
Okay. So first of all, I mean, I will really like to congratulate, basically, in this case, to the candidate, because I think that the effort, the work already been done, as already was also indicated by the previous presenter, is quite huge. So I think that what I like it basically it's that already, and I think like the figure where he showed basically at the different layers how it's building, all a complete framework based on the pieces, that for authentication, for authorization, for communication, and at the end everything is integrated basically on a framework in a consistent way. I think that this is quite nice, quite good. Also because it demonstrates, I mean, the control or the capability, of the candidate to have a very broad vision about the problem and how it needs to be solved. I would say in some sense. I also like to mention that the document, I mean, as a representation of the work, is also quite nice, very easy to read. So it's explained very well. I would say the different steps and how the decision had been taken in order to reach to the final solution. So I think also that is quite important, because many times also that if you have a very good job, and you are not able to explain it very correctly, that is an issue. No, this is not in this case. Also because of the good publications already. I mean, I already met him on one of the conference where already was mentioned. So I was also in his presentation, and I think that was where it is a high quality work already has been done. So saying that, I mean, I think that from the positive part, I would say that when one read the document, as you mentioned, is that for me, I think the main effort or the main advantage basically of the solution, apart from the integration of the different concepts that we already mentioned, for the different functionality that are needed, for the history, for the deed, for the authentication, for the improvement on the access control mechanism, etc. I think that the good thing is that also already have been validated, I would say, in the context of a real IoT scenario, so in restricted or constrained devices, what is also important, so to demonstrate the real, I would say, performance issues that are possible to obtain based on this optimization that already have been carried out. So I think that for me that also give a very good perspective. I have several questions, basically mostly I would say curiosity is more than real technical question in some case. So starting from the beginning, basically from the concept, I would say in some sense. For me, one of the things that I didn't get it initially. And later, maybe because when you mentioned about the research group where you are involved, about this the work of the swarm, I was a little bit skeptical about, how the swarm was already being conceived here on the general architecture, no? I would say in some sense, no? As you mentioned originally, one of the properties basically of the swarm is the collective intelligence. So one of the question I would say, okay, I mean, yeah, in your scenario, you are addressing the issue of the IoT, but really, where is the swarm? You put it that way, or how you envision, if you like, in that sense, to create this collective intelligence that will be that will appear, will rise basically from the interaction between the different components that are part of the system. No, I would say in some sense. No, the other, I mean, I will make you 3 or 4 quick question about the general concept, and later we can go to some concrete data. No, another point I would say is that looking to the approach. Specifically, and then if we go just to concretely about the scenario of the IoT, and basically because you already have mentioned the issue of how to embed basically certain functionality, like the broker in that scenario, can you put in relation the work you already have done with the proposal of this architecture based on zero trust, for example, that already, I mean, some time ago already NIST proposed it specifically for the scenario of IoT? Because I think it's quite related, but I haven't seen that something that you have explored or at least highlight, I would say, in this context. No? And finally, the third generic question, I would say, is that you have done a lot of analysis or performance analysis, but mostly linked to the performance of one device or different kind of device, but the functionality of the different building blocks in that device. But what about scalability of the issue? You also, I mean, I see that there is a certain discrepancies between the performance that you are doing, for example, in the evaluation of the app at the device level, but then when you put it in the context of the global framework, the number of all the interaction are quite increased, because basically also you need to take into account the interaction with the DLT and many other stuff. No, have you already measured what happened where you really want to have as you mean, a swarm? And again, I come again to the idea of the swarm. A lot of devices interacting with each other, and what will be the impact over the global, I would say, architecture in that sense? That is like my first bunch of questions, and then later we will do to some specific ones.
Thank you, Professor Antonio.
I think you're mute now.
Yes. Can you hear? Can you hear now? Yes. Okay.
Yes. Now, yes. Yes.
Okay. Great. Thank you for the great questions. And so, beginning with the collective intelligence. So the answer to this has 2 parts. The first one is that reaching the collective intelligence is like our vision. So we are building the necessary building blocks to get there. We are still not there, but we need to build resource sharing mechanisms, security, and so on and so forth. And besides security, which I already explored, one very important method or way to get there is resource sharing mechanisms. This was explored in a previous publication of our group, where we set up each device having as each agent as a device that is able to share the resources in an economy. So the agent, it can like say, oh, I am a camera, I can do the functionality of getting images. Then if there's another device that can consume images, for example, oh, I monitor the security of the neighborhood, then this device can look for cameras and then contract these cameras and pay for it. And this is everything happens automatically using a score and a ranking mechanism. Then it attributes reputation points to the involved agents. This is something that already works. And these are some steps to enable creation of collective intelligence. Now, more advanced things like, oh, how I optimize these networks for discovery or for working, I believe it's a matter of future works. And okay, then just to make sure of the second question, it was about how to link trust with. Can you please elaborate? You are muted.
I mean, the question about the trust will come later. I mean, here concretely, I'm talking about that, you know, there's an architecture approach being defined by the NIST that is called zero trust. Basically, that is specifically focused on the idea of this kind of devices like IoT and how you can create how you can integrate basically a new device in the context of the certain interactions and so on. No? Starting from zero trust, so how to define basically the basic component that allow you to start interacting with other devices. So what I'm saying that in your scenario, you clearly are doing something in that direction because you define the components, you define the different, I would say, functionality. So my question was, have you in any moment have considered, I mean, the kind of similarities or relation that your approach could have with this kind of architecture based on zero trust?
Yes. So I think it's like a convergence. It's very, very similar. It came from different perspectives, but it's achieving a very similar kind of solution. So you move the authentication and authorization and the confidentiality layer to the application layer, and then the difference from traditional zero trust is specifically that we are also proposing, how do we build the identity layer? The identity layer uses DIDs and so on. But architecturally, the way of using protecting on the application layer, it's very similar to the zero trust architecture. And then finally, for scalability, yes, we have done some experiments, mostly focused on performance. And with evaluating the performance, we can kind of estimate, okay, if this device it can evaluate an access policy on only 5 milliseconds. Then if I grow my network, I don't know, maybe I can have several connections happening, maybe concurrently or sequentially, but in I don't know, several connections in less than 1 second. Then that part specifically is able to respond in an adequate manner of time. And for the other parts, I agree that there are still more work to be done. But for example, we starting with the caching of the documents. I think it's possible to optimize now to reduce these times, and then I think this will impact on scalability. I think reducing the sizes also has an impact because it reduces the stress on the networks, on the constrained networks.
Okay. Yeah. I mean, my point was a little bit, as you said, that there's, I mean, some trade-offs there that need to be carried out because, I mean, it's not the same. I mean, it's not linear. No, the issue that you reduce the performance at the IoT level when you consider the complete framework with the interactions and so on. So consider that. How this will affect, I think, is something interesting also to be evaluated when you are talking about a big amount of devices that are normally interacting. No? Okay, regarding now going to more specific things, or small things that I already said that are more in some case curiosity. For example, although you defined all the aspects regarding the cycle of the creation, basically of the identity and so on, have you considered for example, other aspects like revocation issues associated with that kind of scenario? Because you know one of the main issues regarding also managing capability access token is that they have a short period of lifetime, or in some cases you are not sure about that still is valid the credential being provided. No? Also, in other cases, the revocation, in some sense, of a possible identity also will have effect on the global behavior. Have you already seen, not necessarily for this project, but basically also expanding basically a little bit your framework, taking into account this aspect?
Yes, I have thought about it, although I didn't include explicit mechanisms. I think they can be added. And so there are a few places where it could happen. The revocation of a deed could happen only by the user. It could, we can add a specific operation to say that a specific deed is not valid anymore, and then when it's tried to be resolved, it will be return an appropriate message. Credentials can be revoked, And usually on the self-sovereign identity community and on the standards, this happens by using revocation lists that are anchored on blockchains or similar. And for the token, I think, I think lists would be grow too large, and I think the best approach would be to have short. It's a bit. I think it should be used as a best practice. For example, use default short revocation, auto revocation time, short expiration times for the token, and then you can just renew asking again for a new verification of the policy, because the policy can even change. The user can go and change the policy. Then if you have a short expiration time, then you can just reevaluate the policy, and then you can deny the token generation.
Okay. Yep. I think that this is quite, is a quite a research challenge, I would say, in this moment, how to integrate all of this in this kind of scenario, and it's not an easy task in that sense. Also, I mean, regarding, it's not for the revocation, but also, for example, one issue, and you know that we are interested because of the scenario that also I mentioned you that we are implementing in other projects. One of the I was at interest point of all the solution based on the identity of the IoT and how they can be linked to the deeds and so on is connected with the idea of the bootstrapping. In that sense, no? How to launch, basically, in that sense, the process of all the process of registering and creating identity, starting from a trusted anchor point that defined, but basically that this device is something really true, I would say in some sense, no? Or it's not a fake device, but it's a device that you can be confident on. That's why you give him identity, and starting from there, you launch all the process. No, have you? Because I haven't seen something, and either you are just considering exactly the initial identity assignment. How you envision this initial identity assignment to the device? Who is in charge of providing it, and how it's going to be created from the initial steps, basically?
Okay, so I think an identity life cycle needs to be modeled. Then you have unprovisioned devices, and then when a device starts to work, I envision that it generates its own deeds and deed documents, and the device itself can store it on the blockchain or on appropriate ledger, if that is the case. And then that's the first step to create the very identity for the device. And then the next step, as I see, is to associate with an entity that will be the owner. That can be a person or organization. And then this needs some sort of provisioning protocol, just like EAP and other similar protocols for provisioning. Then you can provision a verifiable credential, and then you build up from there.
Yep. No, indeed. I mean, basically, this is something that we are envisioning, like the good approach. Okay. Then one small thing that for me was a little bit not shocking, but maybe, I don't know, maybe it's in the future design, because in your model, actually, if you go to the figure, for example, where you present your ABAC model, basically in each device, you're assuming that you have this agent, basically, and that you have a swarm broker that basically is all the one managing the policies and so on. No? And I think that the good thing, I mean, is that you really have demonstrated that all of them can fit really good on constrained devices. But do you consider in your architecture, in some sense, that maybe the connection between the agent that you are providing in the device could be decoupled from the broker, in the sense that the broker could be an external entity that will provide this functionality on behalf of the different agents? Thinking about in the case of extreme devices, or just because, I mean, the device at the end, there's no capability to put all the components all together.
Yes. So actually, the design of the swarm broker was the work of my advisor, Liza, and she envisioned that the broker should be heterogeneous. So work on constrained devices, and even if you have a very, very constrained device, then you can offload this broker to a neighbor one, or yeah, as the next device.
All communications, we use this idea of microservice of the broker and everything, so it's very flexible to have this patch.
Yes.
Yep. I mean, I think that the only problem there is that you need to have a trust model already between the agent and the broker, in some sense behind, because at the end you are delaying, or you are relaying. Sorry, not delaying, relaying certain security functions outside your own capabilities in some sense.
Yes. Usually the broker will be in the same device of the agent, and they will have this trust, right? Usually. But it may accept other kinds of structures, but then it will be something like of the same manufacturer or something like this to have this. The broker would be like in a gateway, right? Something in this way.
Mm-hmm.
But our main vision, the regular situation would be to have the local broker together with the device. And you could even have a broker with less features that would accept to having this. So this is the main idea.
Yeah. No. I mean, no, that's what I mentioned, because I mean, what for me was surprising in some sense, a good surprise, was that all the implementation at the end fits basically with in a real constrained devices, no, in that sense. So that's mean that okay, but I mean, you never know that what will happen in the future if more and more constrained devices will appear, and how this model can be distributed in some sense, as you mentioned, having a kind of computing capability outside their own device. Okay, and just to finalize, I think, okay, yeah, we are talking about that. Okay, and the only final point for me is a little bit strange, not strange, but just for you to comment it, is that when you present on the page 75 the size basically that you are, or the performance in the case of the EAP, when it's being executed in the device, it is really very good performance. I mean, you're talking about the millisecond for processing the number of policies and so on. But when we go to the figures that you have at the end with the integration of all the different frameworks, so I think it's page 89, or yes, 89. I'm looking at. I understand that it's the green. The green part, basically, of the figures that you already have there, and there the time are quite a little bit more greater than in the other cases. So I mean, I understand that the broker processing is also have another things, but for me the most I would say the significant part should be really the policy evaluation. But here, I mean, it's quite diverse, basically, the values that are presented here. Can you, maybe, I mean, I'm interpreting it incorrectly, no? So can you try to explain why these values that are varying in the two cases?
Yes, just one moment. I am actually, it was a different computer here, so I just downloaded
okay.
Next here. Just one moment.
Yeah, it's a picture, the figure that you already have with with this in color of the time. I mean, it's you already show it, I think. The time metrics for the setup, in the case of Bob, the broker.
Yeah.
You know, I mean, and you saw results.
89, right? Mm-hmm.
Sorry?
Yes, I just found it. Page 89.
Yes, exactly.
Mm-hmm. Yes, and anyone specific of the tracks?
No. In general, if you compare basically what you mentioned aquí, for example, you can see the green, basically. I mean, green is quite different in one case and in the other. Quite basically, I mean, we're talking about the one that are the one that is quite reduced is the one that is executed on the device. Indeed, that's my understanding.
Yes.
In the broker
is that unfortunately, I think these graphics, the colors have different meanings between them. So this may be a point that I can improve. But usually I also find some parts of the analysis that actually, surprisingly, when I do the serialization, for example, for the implementation in Python in the single board computer, it takes some time to create the classes and serialize it from JSON to CBOR, for example, in the Python implementation when integrated as a whole. And then I run a profiler actually, and I identify these parts. So yes, I think that is the main reason, because there are more things happening than only the parts that when I integrated it.
This
Yeah.
is something that we will do now to have this implementation in C for the constrained devices of the whole platform. Because during this work previously we had an implementation on S. That was, it was on RTOS and it was on C, and it was really optimized. But then with Geovane's work, it changed a little bit, the data model and everything. So now that he has finished this changing, now we can do this implementation for constrained devices. So this is some project that we have now for the next steps. Yeah, because this work was evaluating with Python, so these measurements was not so adequate, but I thought I asked to Geovane to include this because I feel that doing something for the swarm, we have to have this vision of constraint, even if it's not yet finalized the whole thing, but we could show all the advances that he did for the constrained device that we think it's really valuable. Yeah.
Okay, thanks. I mean, it's totally understood. It just was, as I said, a kind of curiosity. Okay, that's all from my side. I mean, again, I want to congratulate you, obviously, as your supervisors, in that sense, for giving you the support and guide you over this nice work. And again, hopefully you will have a quite success in the future with new publications and results. Thanks.
Thank you very much, Professor.
Thank you very much. It was really nice to participate. Geovane was reminding me that the first paper that I sent to him when he started the PhD, actually it was the master, and then we changed it to PhD, right?
Yeah.
And it was a paper of you, Professor Antonio. It was, really nice. We have inspired by you as well in this work.
No, indeed, as I already mentioned, we already are involved in a project. I already, Geovane, I commented him about this Tosthenes. Basically, we are expanding exactly in this same direction. So it's quite nice, and we can see a future collaboration there, for sure.
Really nice to start collaborating more now. So thank you. Now I will give the word to Professor Pedro Maló from Lisbon. Please, Professor.
Okay. I hope that you can listen to me, just to check.
We can.
Okay. I no longer can see Laisa, I only can see this, but okay, it's okay, because I can see the candidate here in this big screen. No worries. It's a bit slow, but no worries. Very good. Now it's easier. So good. So thank you very much to invite me to this PhD Viva. I wrote here a set of questions and a set of issues. First, I have to tell you that I'm not really a specialist on IT security, whereas Professor Scarmetta is, and I know him. But even so, I have several apps that make me knowing a bit in detail this subject. One is that we are developing IoT devices in the company where I own, right? And we have some issues with security for sure, and also authenticity and identity of the devices, in the sense that we need to update the software of the devices constantly or from some period of time, and we need to trust this updating of the software or firmware of the devices over the air. So, of course, we have some security and some trust and some authenticity and identity in place for that. I'm also involved, I've been involved in some projects, European projects on IoT, large-scale experiments in IoT like the ARMOR project. And now we actually, by chance, we are coordinating a new project. We are not supposed to coordinate, but the Brexit is doomed here in Europe, as you might have seen several manifestations of that. And what's happening is that we have been called to coordinate a project where it was supposed to be a UK partner, and is exactly focusing on advanced security for safety assurance for medical device IoT in what is called the Internet of Medical Things. So it's really strong on IoT and strong on security. So because I know that project, I also am able to go a bit deeper into the questions. And so let me just give you an initial set of comments, and then we go in more detail. So reading the document, I think it was a very good work, okay? Even the English is good, which is not so common, okay? Very good English, maybe you have also good support on this. And the contributions are quite good.
Thanks for the mother, that's English teacher, right?
Okay, very good. And the contributions and the advancement from state of the art is also quite notable. And it feels and understands that you did a lot of work scientifically, technically, and also some use case, some development. So that shows. Looking at the presentation that it was done today, I saw that you explained a bit more in detail the contributions. And also the application case with the police, which is something that is not in the thesis. About the first one of the contributions, I see that you have in the first chapter, you have there a small section, 1 page with the contributions. But today you were a bit more detailed and explained much more in detail. So maybe it makes sense to include that also in the thesis. And about the second, I presume that this work with the police may be a new thing, more than it was the writing of the thesis. So maybe it's not there yet because of that. And it doesn't need to be. I'm just, I don't know. I'm just saying. Okay. And also another thing you gave, you provide today something I had actually a question here, but I would question about that. But maybe you can give it now. You gave some insight on the next steps on the future work, which is something that you didn't give in the it's not in the thesis, not there, and also on the limitations. So I was going to ask you what are the next steps of this and what are the limitations, because there are always limitations, right? Otherwise it would be perfect and the world is perfect. So okay, you did the framework, but there are limitations and some constraints. So that was actually the first thing I would ask you to put actually this next steps and stuff inside of the thesis. That would be nice. Maybe giving it a bit more detail, because you just gave it 3 bullet points, right? A slide today with 4 bullet points. Maybe then you have the thesis to write 2-3 pages about that. Would be nice. But I would like to hear a bit more about that. So what are the real limitations that you have in this framework compared to what you've seen, right? And based on that, well, what could follow, right? You could follow many things, but what are the things that you really would like to follow personally, and also with the work that you see, maybe the funding that exists? So what are the really 1 or 2 research directions that you might follow?
Okay, thank you, Professor Pedro. I think those are very interesting comments. And well, I think beginning with the limitations, yes, there are. So, for example, currently we have validated the integrated solutions on embedded devices, but this device could be more constrained, like battery-powered devices. So it's a matter of the implementation, but as of today, it was implemented in single-board computers, and this could be ported to smaller device. So this is one limitation. The implementation of the DIoT-COM protocol, although it reduces the overhead, it could be even further reduced. For example, also showing here a next step, we could use interactive key establishment approach. For example, using new emerging standards. There is one that is called EDOC, which is called elliptic curve Diffie-Hellman over Coze. So this is a smaller, even smaller overhead. So I think that's a very interesting approach to tackle how to combine this, because it's already proposed. Let's roll back a bit. DITCOM came from the web environment, so I adapted it to work on the IoT environment. But then there is the other approach, which is take a protocol from IoT environments and make it work with self-sovereign identity primitives. So this, I think, it's a very important, very interesting future work. And finally, I think one important step is to test or simulate or create larger networks and assess the scalability of the system. So that's a point that for sure requires more investigation, more thought, and more execution, and more like really verifying that this can work on large, like hundreds, thousands, or I don't know, millions. We want trillions of devices, right?
In this direction, we have also another work of another student that is evaluating how can we make this test of such big networks, and he's trying to build some strategies in this way, but it's still going on. So
yes.
Okay. It is nice that you mention actually two aspects, which are actually where I go now in a minute, after we enter a bit more in detail in the thesis, which are about, you said, more constrained devices, and you said also about more large-scale scenarios, more large-scale testing, okay? And this is actually where I would go, right? Normally, if I would be the opponent of the thesis, right, in Europe, normally we go page by page, right, and criticize, question, not criticize, question the pages, right? Being a bit formal, I will go not page by page, but I will, because time is limited, I will go on 3 or 4 main highlights here. And one is on the hypothesis, okay? Because it goes in that direction. If we look at the hypothesis that we pose, it says, okay, the hypothesis of this work is interactions among very large fleets of computer devices, even the constrained ones, that can be secured without directly assigned interactions or without centralized management, right? And when we are scientifically bound, right, when we talk about this, I ask you, so what are you talking about when you say constrained devices, right? So, because you say more constrained, I think I've written here that in some places you even write highly constrained devices and network. So we are talking about for sure limited resources like memory, processing capacity, power. We know that. At some point in time, we also talk about single board computers that you tested. Then we talk about processors of 32 and 35 megahertz. Then you talk about 512 kilobytes of RAM. So I've seen it written here and there, elements that I understand that might be constrained devices. But what are really we talking about? So what is your target in terms of how restrained device limit do you want to? So what is your focus? Where do you want to go? This is a question because I haven't seen a definition in the thesis of what is a restrained device, right? Or a highly restrained, and this would be nice also to put there, right? To be clear, even in the hypothesis what you're talking about. Maybe I would like to hear from you on this.
Okay. Yeah, very interesting. So our main goal is to achieve essentially battery-powered devices. So because these are sensors that can be embedded either in forests, even on our body, or sensoring cities. So we want to be able to integrate battery-powered devices with this, which means I think devices on the size of Pulga that we presented. But I agree, I could add a definition, for example, considering the classes of IoT devices that are defined by the IETF RFC. I think that could be
correct.
A good definition.
That is where I would exactly go. So there is the RFC something, I don't remember now by hand, but correct. It describes the types and the scales of limited device. Because when you are saying energy power device, for sure, my iPhone is energy powered and it's a computer, right? To be honest. But then you say, okay, pulga size. Okay, now we're going somewhere. So it will be very important to be very clear what do you mean about what we constrain device and what is your target, right? For the thesis and maybe for beyond. That is one question. And then still on the thesis, still on the hypothesis, then you talk about very large fleet of devices. Again, so what do we mean about large fleets, very large? So what is the number and why? So because how many devices do you really test and simulated in evaluations? I see that you have this smart use case scenario, but the number of devices in the smart use case is I think, very low. Sometimes I try to picture my home and see where I can put IoT. And to be honest, I have some small devices in each plug to measure the consumption for sure and to plug it in and so. But overall, I don't think I have more than 50 devices at my home, right? IoT, to be honest. And cooperating with each other, maybe even lower, right? That they are cooperating together for a given purpose. So maybe the use case is not the best, but my question is, how many really devices have you tested together to test these algorithms, these methods? That's one question. The other question is, so what is the scale? So when you mean, because your hypothesis needs to be sure, needs to be tested, right? So how did you test this very large hypothesis that you see in the hypothesis statement that you put in the first page?
Okay, so I'll divide the answer in two parts. The first one is what we want, and the second is what we already tested. So when we talk about very large fleets of computer devices, we are considering that, for example, we will be able to reach 1,000 devices per person, or the order of trillions of devices in the world. So this is the vision that we have. So our work must consider this as a goal. And then what we actually have tested, as Liza said, we have another student doing a master's. So he has tested part of this framework, because when his master is to do scalability tests of swarm devices. And he's using an emulation / container-based approach to simulate dozens of IoT devices. What we are able to test now, I believe it's around 50 or 100 devices. It's at this order. So we run them using the exact code from the Swarm broker and the Swarm lib, and using the agents, communicate and authorize and use the policy, everything I show here. So we have tested with up to 100 devices, in the order of 100 devices.
Yeah, but
okay.
During Geovane works, he was evaluating some parts, considering most bigger cases, right? For example, for SmartBack, and to check if the parts are scalable, right? But they are not real implementations with trillions of devices. We don't know yet how to test it, right?
Yes.
But the idea of the swarm is to have this open platform to share resources and have cooperating things in the world. So it's a vision for the future. We were inspired by Professor Yan's work as well. You were talking about the home situation, but for example, we see that you will have we think about sensors, implants on your body, for example, and having all the devices, the television, the lamps. But of course, it's not yet a reality, but what we are doing is going to this vision of an open system, right? Having all these computer devices working together. And this is what we call this collective intelligence. Now we are focusing on this collaboration, but even when these devices are more and more smart and intelligent, this collaborative, collective intelligence will be built.
Okay. Yeah, it's great, and it's good that you have a vision. It's just that that vision is not tested in the thesis. So in the sense that when you put in the hypothesis that you're going to test very large, so there is the hypothesis reads very large, I'm expecting that in the testing and evaluation that is provided, which is not. So maybe I understand that sometimes people, and we do that all the time, tends to put some buzzwords, and I think Antonio already said about that, some buzzwords to make it trendy and so on. Swarm is a nice buzzword. But maybe if we move away from the swarm, right, and you just say that you are making secure the IoT secure, and you're providing some new properties, right, which is self-governing authentications and so on. Maybe it's already enough, right? We don't need to put these crazy buzzwords, which then gets you into trouble. Because when you say swarm, you go large scale, and you go large scale, I go complexity. Complexity means, so what is the number of devices for the interactions to be non-linear, to be with difficulties which are not present when you have few connections. So then that is the problem starts there, okay? And sometimes it's better that you just propose something that is working and it's nice, and the limitations might be that, okay, I haven't tested this large scale, this is next step, okay? Without promising that we have a large scale system that it works, but then you don't provide the proof for it, okay? So moving on. So on the hypothesis, I'm done. I had here some comments, but I will defer from them. I will talk on the state of the art a bit. On the state of the art, I have two comments that you could have gone a bit further. There are two things on IoT, things that I think would be nice to explore. One is the European Alliance of IoT, which is the high-level architecture that is new, it has one years old or something like that, December 2020, which is an architecture it's basically the European architecture, right, for IoT, let's say like that, from the Alliance, and that documents are online. And there are security provisions for that and security aspects written there. So it could be interesting to take that also. And also the Industrial Internet Consortium, the American. You also, because you guys have a joint focus, right? Sometimes you look at Europe, sometimes you look at the US. So it's nice to have a joint view of this. And so the American Internet of Industrial Internet EAC, where they have the comment. Okay, there is the document which is named the Industrial Internet Security Framework, and it is very strong on security and on IoT. So it explains all these aspects that you're talking about. So maybe you should also look at that to see how it matches. Okay, this is one comment. The other comment, which is more difficult for me, is that I think what you are proposing here, and I know a bit of security, is that you are proposing what today industry calls the secure element, right? Or what Apple calls the secure enclave, right? It's basically is a chip, is a system on chip that basically is device protected and gives all these aspects that you're talking about. So store confidential data, cryptographic data, giving identity, and so on and so on. And I find it a bit sad that you haven't explored the secure element. If you go online, you'll see a lot about technical details about the secure element. So what is inside of it, the architecture, the elements is very similar to things that you are proposing. Okay, in some parts you are a bit different. But I think it would be important to you to explore the secure element, which is basically what the industry is using today on IoT, right? Everybody has a secure element there, and the secure element is what provides the end-to-end security that we are talking about. Okay, it's embedded on the device as a chip that you can buy from several providers, and this is more or less granted. So it would be important to explore that in detail. Okay, I don't know if you want to comment. Maybe you looked at it, I don't know, for sure you can comment.
Yes, I think it's a great mention. It definitely should be mentioned in the text. I think there is a difference. Maybe I overlooked it, but I think there is a difference. The secure element, as I see it, it's more focused on hardware protection of your cryptographic keys and authentication credentials or certificates or whatever you use to protect. And the proposal here, I see how that has an overlap because it's embedded into the device, but I think the proposal here is also it considers the architecture as a whole. So how I enable everything to work on a device, and also how the protocol should work, and how the identification, specifically how the syntax and so on and so forth, and the protocols. But yes, I get what you said, and I think it's a good opportunity to trace a parallel, because, okay, how can I go and really implement it on constrained devices and really make it secure, for example, and then I can guarantee that my private keys won't leak. My credentials, if they are sensitive, they won't leak. So yeah, I can put them in a secure element. I think it's a great addition.
Yeah, correct. That's exactly what I think. You are proposing more, but you have to live with the secure element. It's there. So how do you live with it? So how do you integrate with it? How do you propose this? Maybe this is a secure element plus plus. You are proposing a next level of secure element. I don't know. It's no problem. So, but I find it a bit limiting that you don't talk of secure element any place. I never saw one mention to that. So it's important that you embrace it and understand how can you touch it. Okay. So this is okay. Moving from state of the art, not to focus too much. I was not going to talk a lot of the framework because I think Scarmetto was going to do that, and he did it, talking more on technical aspects. So I didn't want to go so technical. But on the implementation, on the framework, because you have the framework, right? You describe the framework with the layers, it's okay. And then you have a framework implementation, and then you go to evaluation and testing, right? The framework implementation is something that I think could have two purposes, right? At least from my perspective. Purpose number one would be to explain a bit on the experimental setup for the testing and validation of the framework. So what were the systems that you tested? What were the characteristics? How many of them? In what conditions? Controlled? So changing what locations? Whatever. Okay. So maybe a bit on that. And the other thing that I was expecting there was to provide guidance on how to use the solution, right? And the guidance has to do with several aspects. One, as the first colleague that could talk, the first question was exactly on that direction. So how do you use it, right? How do you go to the store and how do you use it? But the question is, who is your user? Who is the user, the end user of your solution? Because the end user of your solution is not really the guy that goes to the store to buy it. The end user of your solution is the guy that integrates these solutions into the devices, right? So is the guy that will develop the secure elements, right, to put on the devices. So I was expecting to see not a use case like the smart home use case and so on, but use cases on how to deploy this in the devices. So if you have a constrained devices, what can go? A more or less constrained device, what can go there? If you have a computer, how can this go there? So the levels of service that you can provide depending on your capable resource that you have. That was what I'm expecting, and what I get there is neither one, which is a bit sad, because even I think that section is small, right? It's a very small section that stays there in the middle. If I recall right, 1, 2, 3, 4 pages and 5 pages and so on. And basically you talk about things and then you give an example, a very brief example with some code in Python, right? Python code saying, okay, let's say I create an agent with more bleed, and it's done. So I think it's the chapter that is more poor in the thesis, which actually is just a very small section there. And I was expecting to see either one or the other, right? And I didn't see none of them. So maybe you'd like to see to explore a bit on this detail, okay, if you want to give it a more proper focus. Even you don't need to, if you are doing a science thesis, right, with which focuses science and technology and validation of this, you don't need to put this, okay? This is an add-on that you put for others to know how to use and so on. You can even remove it if you want, okay? Because the important is the evaluation and the testing that comes after. So maybe you can check on that and see if it makes sense to have a so poor chapter which doesn't really provide any good thing and value. Maybe it's better to remove it and quit it, and you check on that, okay? If you want to comment, you can comment anytime. Maybe I'm doing too much, but you can comment for sure.
It's okay. Yeah, I think it's great notes about the platforms. I mostly described them in the evaluation, but I agree that writing them in the implementation, supposedly we keep in it, So that would help the reader to have an idea of what kind of device can support what kinds, what parts of the implementation. This could be added to the table or to the text next to the libraries, for example. And about the description or instructions on usage, I think I could, because we have some documentation on the online repositories with this implementation. So maybe I could just write a paragraph instruction, okay, you can reach to this URL, and then you find the documentation on how to use the system.
Okay. If you want, you can even skip the chapters, okay? You can put the first chapter, the testing, which is the important one, and then you do a second chapter after that, which is really to explain how it uses, right? Because this is a non-mandatory in a thesis. It's not mandatory. It's important. It's nice to have, very nice to have, I agree. But the important thing is the testing, okay? Which is the one that comes next. And so to finalize, not to give much more time, I'm just going to focus a bit on the evaluation and test, which I think is how it goes. Because this is the part where the testing is quite important, right? Because you test basically you test whatever, in this case the solutions, in view of the hypothesis, right? So you go to the hypothesis, you test it, and then you give, okay, the hypothesis is valid, right? Because this is how it works. And I understood that you have tested each of the layers of the framework, each of them, it's okay, right? And then you also evaluated the whole thing in the context of that use case, which is as a complete interaction, it's also okay, which gives a specific validation and then an evaluation. Actually, when I do a project proposal here in Europe of research, there are three terms that are normally split together, right? One is evaluation, another one is testing, another one is validation, right? When we call it testing and validation, normally we are testing and validating science and technology, right? The aspects of technically. When you are talking about evaluation, you are more about how the system performs and works for users and so on. So sometimes I even take it a bit on this confusion. You have a bit evaluation and testing. It's not a problem, but maybe that's also a bit of your interpretation. But the questions I have is, I think that you say that you use the stride web model, right? And the stride, yes, I know it, I know that. But why did you use that one? There are several others. There are others, some specific to IoT. I know that because we did in Armor some of them. So why do you use this one? And the other thing is that I saw that you took from stride the threads, the several threads, right? But I don't think you have tested them, right? You do some verbose testing saying, okay, this works because of that, and spoofing works because of that. Is verbal, right? It's text-based proof. But you didn't test it, right? You didn't did a kind of a test bed where you attack the system to see if it works and you tamper with it. And you put a man in the middle. That you didn't test, right? You didn't do the testing of the security, or did you do?
Okay.
That's not clear to me.
Execute formal security testings, but I didn't put in the thesis, but I did some trivial testings to verify that the proposals were actually executing, and I could break authentication if I was a man in the middle. I set up a proxy in the middle and I tested it in a practical way. But this test I didn't put in the thesis.
Maybe it's good to put because that would give value to this text proof that you just write text, right? You say, okay, this works because is more conceptual testing, right? It's possible, I understand. If you want to do a formal testing with mathematics and so on, it's stronger. But if you have some simulation or experiment that gives value to the proof, that would be nice because it's limiting a bit, okay? And I think, I don't think that I have so many questions. I'm just curious about one thing that I could ask you. I know that today, Apple, I'm talking about Apple because they are very advanced in security. They are basically, when you are starting to interact with websites and so on, they change the MAC address of the device dynamically, right? So basically, they change the identity of the device. So in order to avoid the trackers, right? And you know that Facebook is fed up with it. Even Google is annoyed with that because now it's harder to track. But my question is, how with this framework of yours, how do you handle this dynamic identity changing? Because the identity will change, right, all the time. So how this dynamicity will work with your framework?
Okay, this is a very interesting question because in the self-sovereign identity community, there is an approach that considers what is called ephemeral deeds. So so the idea is that you have one main deed that is yours and is private. Then every time I communicate with someone, for example, I send a message to Liza, I create a new deed to talk to her, and then a different one to each of my interactions. Usually these are called peer deeds. But there's a cost to that. First, you have to manage all these newly created deeds and with associated documents and private keys. And also, how do you link the deeds to the verifiable credential? You need some form of, there are ways to do that, for example, using zero-knowledge proofs. So you can, without revealing your own deed, you can prove that your credential refers to your private deed. But that's usually something that takes a while and even more computationally expensive from the cryptography point of view. So that is an interesting approach, but I think it has some overhead and it's a very interesting research to tackle.
Okay. And final question, if Marcelo was here, because this is a question interesting, because it goes to your field, which is security of research, but also then to electronics, which is strong place where Marcelo works, right? I know that there are these, and I've seen actually you have a reference to a document, I think is named from Sue in 2020. There is how do you say, a reference in your document, which they talk about the POOF, right? The POOF for doing identification and device IDs. The POOF is what is called a physical unclonable function, right? I'll tell you, if you don't recall, I'll tell you what it's about. It's basically, you take the ID, is like a fingerprint, right? When each one of us has a different fingerprint, right? And the device also has a fingerprint which relates to the fabric, the way that is manufactured, the device, the small differences that the resistors, the components, everything that is put there creates small difference from one device to the other, and you can create from there, with some computation, you can create some POOF, okay, which is an ID that is locally and globally unique, right, with 99% We like the same because some of us have the same ID. So if you have twins, the same. So my question is, have you explored this also with Marcelo to go in this direction of the POOFs and on the PULGA and on the devices that you have to explore this kind of things?
We have discussed it, yes. We have discussed the creation of POOFs. And for now, we are using random number generators. But we also have that question of when you use the POOF, then you have even more fixed identifier. That's even harder to change. So how do we balance that? We're still evaluating, but yes, we consider this option.
Okay, good. I would like to know, it's just a curiosity, because we are going in that direction in some of the projects, and I would like to understand how it works. Okay, good. So I took a bit of time, but I wanted to give a bit of our time to Geovane, because it's proper when you end up a PhD that it's a good moment, and I think it's important to you to have a good time, okay? And congratulations for this work, okay?
Thank you very much, Professor Pedro.
Okay. Okay, so thank you very much, Professor Pedro. With these valuable comments, now we will go to the discussion of Professor Pedro Froze from University of Uberlândia here in Brazil. So thank you for participating, and go ahead.
Okay, thank you. Can you hear me?
Yes.
Yeah, okay, thank you. First of all, thank you, Geovane, and thanks to Professor Liza and Professor Marcelo for inviting me to this examining board. Thank you. Thanks for your presentation, Geovane. You showed a lot of ease and dexterity with the subject. Congratulations. One of my projects, I am working on a focus on IoT home communications using unsupervised machine learning algorithms to assess the health of home traffic. I am particularly interested in identity and entitlement life cycle, so this work particularly caught my attention. So it was very interesting to read your work. I agree with comment the question from colleagues who have preceded me. The dissertation was very well structured, with good writing, organized each chapter subject, with a logical organization of ideas that allow a good understanding of the thesis goal. Congratulations to you and your advisors, Professor Marcelo, Professor Laisa. The literature review chapter is well structured with a good reference. I agree with you. Perhaps the only comment I would have in this chapter is that I would be nice to have some more Brazilian references. Since there are cutting edge works in Minas Gerais, Pernambuco, Paraíba, Santa Catarina, to mention a few. And so it would be fine if we had some reference from there. By the way, in the chapter, I liked very well Table 1. It was a good initiative to quickly compare the works related to your proposal. It was a good initiative. I have some questions, some comments maybe. In chapter 3, in figure 2, when you present your framework, the layer confidentiality, I asked me if it is a layer in your framework. Considering that confidentiality is I'd say a keyword in security dimensions, then I believe it's not part of this picture, or at least it's one level below. Maybe another name could better express what it does. Please make your comments.
Okay, so yes, this part I was deciding where to exactly put this layer. As you can see, it also goes a little bit below authentication. So I'll explain my reasoning behind this, and then let's see where it goes. So the idea is that, let's begin from below. In the identification, I have the foundation where I give identities that enable to tell the devices apart. Then on top of that, I need to send messages. I need a protocol to send messages that cannot be read by anybody else. So that was the reasoning to proposing this layer as confidentiality. So on top of that identification, I also enable providing secret messages. And then,
okay.
Yeah, so that's the main idea.
Okay. When I read the confidentiality, I think one subject, and when I read your chapter, I understood what you would like to say. In relation to this figure, you present an organization, the layers of your framework. I think it was very important to describe the interface and the services you provided for the underlying layer and user layer. This will decouple your framework from the technology used at this moment. And I think it will turn your work more understandable. for other readers. So it's a consideration I would like you make in describing the interfacing services in your framework. In session 3.1.4, when you specify identification, I agree with Professor Stameta. I think using blockchain is a good choice. I wonder if it would be the case to expose the life cycle of identities, since eventually it will be necessary to revoke, for example, an access. So I would like you comment more. Yeah, I think it's important you drop some lines telling about the identity life cycle in your architecture.
Yes, very important. Now that you mentioned it, it's something that is in the implementation, but it's not here in the description. So yes, I can update it. But the main idea is that the device starts in an unknown state or not identified. Then it auto-generates its own identification. Optionally, it registers on an external registry. And after that, it can do updates on certain parts of this. It cannot update the deed itself because it's unique, but it can update, for example, the service endpoint, or it can do key rotation if it decides to change a public key. And then after that, it's actually, I think it could be modeled, but I think it could also be revocated. For example, you can send a message, then you disable the device. So yeah, I think it's something that can be mentioned. Mm-hmm.
Okay. Because some device could be hacked, so you needed to revoke them. Okay. I have just one more comment. I would like to hear from you. In your presentation, you told us about your future work, but I would like to hear from you of your future you thinking in terms of business, in terms of the use of your architecture in the real world. This is the last question I have to you. Thank you.
Okay, thank you, Professor. So, yes, I think it would be very interesting to be this, as I discussed it earlier, if it was possible to evolve it on some kind of specification to enable even like more collaboration and assess and finalize. There are parts that can improve for sure. We are already using actually parts of the framework in some IoT pilots that we have here. For example, the police one that I gave the example. So we plan to continue this integration with the Swarm. And yeah, that's it.
Okay, thank you. Thank you, Liza.
That Geovane was mentioning is interesting because it's a BNDES project, and the idea is to have tools and cases that use open platforms that could be spread around the country, and it will be highly disseminated. So it's really a good opportunity to the Swarm framework and to the security framework to be spread out and to be disseminated.
Fantastic. Thank you.
Thanks a lot, Professor Pedro.
Okay, so thank you very much.
I finish.
Okay. So thank you very much. Now I would like to invite Professor Flávio, that is our collaborator also in some of the works of the Swarm, and I think he could give good discussions as well.
Thank you. Can I move there? I'm going to be very brief anyway. So thank you, Geovane and Liza and also Marcelo for the invitation. I'm really pleased that I had this
to follow partly, but the evolution of Geovane's work. Very glad to be here. I was prepared, so I'm not going to be disappointed by being the last one, so I had very little to add. So it's okay. But I still have some points. I have, first of all, to second the compliments. I think the work really good. The thesis was really well written. It's very concise, but also clear and very complete to my view. And it's well structured, but not only the writing is well structured, the project was very well structured and very complete. You can see it through the thesis, so I'm really happy to learn from it. And at the end of it, I had only 2 questions, but by coincidence, I had a day-long meeting yesterday about a subject which is not directly related to your work, but kind of started to answer those 2 questions that I had. And now, after all comments and the whole discussion further by the other colleagues in the board, I think I'm going to change the 2 questions by 1 statement, which I'm going to make, and then you can comment on that. So I'm going to make a statement, it's not really a question, and you can see whether you agree or disagree. There's no wrong answer. So if you disagree, it's fine as well. And my statement is like that. I'm going to talk about what was the meeting about yesterday as I go with the statement. And my statement is, swarm computing, in the case of your thesis, is actually a scenario which you use as an inspiration and as a source of ideas and ways to ground your work on concrete examples and scenarios. But your work is not really so much tied or constrained by the notion of swarm computing. In a way, every network of agents or agencies, which gets closer to the meeting I had yesterday, which has some attributes to it. It's open, it's managed in a decentralized way, and it should be self-regulated, requires the work that you're doing. So when you talk about security, it's security about agent interaction in a network with some very broad notions. Swarm computing happens to be one scenario in which these attributes are present, but your work, considering the issue or the possibility of building standards out of your work, for example, your work is not really constrained to those scenarios only. For example, when you think about the structuring of tech district for a city like São Paulo, which was the subject yesterday, or when you think about organizing a marketplace in a self-regulated way, so we don't have a centralizing, controlling agency to manage the transactions. Security, in the way that you mentioned, is relevant. And the only difference comes from what will come after that. Because when you talk about marketplaces, for example, people or agents participating in the marketplace will be interested in perhaps more sophisticated notions of trust. But every notion of trust, so whether you deliver what you pay for and whether you pay for what you get, that kind of thing. But every notion of trust requires security in the sense that you build. And the solution that you provided is a good solution for whatever scenario that abides by, that complies with these attributes. that's the same thing.
Okay, yeah, very interesting kind of a provocation to look outwards, right? So I think there are a few things on that topic. So for example, there's a link with zero trust, which was mentioned earlier, which I think it's not a coincidence, because you're trying to go above network layer security, and then you try to create more flexible approaches where you have these agents interacting at the application layer. And then you have this kind of agents at the application layer. Then you have multi-agents in a very broad sense. And it has to do with this work that we developed as well. One thing that I think the second thing is that the swarm, I agree that's it serves as an exercise, a very rich point for exercising what we need to build security in a decentralized and self-sovereign approach. And I think the main difference may be even it's like an added constraint, an added requirement that we have is to work with constrained devices or in a more broad way with cyber physical systems. Because we need to consider the environment, information, and also consider the limitations of the constrained devices. But yeah, I agree that it can be used as an average for other purposes.
Yeah. Good. So now, since you agree, I think that's good. That can be a good different strategy for stepping further for the whole swarm initiative, actually. So building blocks that we build are not constrained to that. Once they're built, they're assembled towards the swarm. That's fine, but the side effects and the byproducts, they can be at least as interesting as the one.
We usually in our papers, I don't know if you noticed it, but we try to put the contribution, and then we put two dots, and then we put and apply it to the swarm case or something with the swarm after these two dots. But because, for example, the IoT POM could be used in any case, right? We have the smart app, that's the policy. It can be used for, it can be used even to people with crashes, with tags, to enter, with badges, to enter in a building and things like that. So, and we try to state that in our papers, to have this, and then we have the two dots, and they say that it's used for the swarm or the use case swarm, but actually, we have this contribution. And what I think that was really nice of Geovane's works is these contributions in many things of security that can be used for IoT, for other usages, and he tested against the